So question 25 is a challenging problem. So it's a probability question. So in this question, we're given this figure, and we're given the outer circle has a radius of 6, and the inner circle has a radius of 3. And the 3 radii divide each circle into 3 congruent regions, right? So you have this radii, this radii, this radii, the 3 radii. They're going to divide the circle into 3 congruent regions, right? So this is 1 congruent region, 1 congruent region, 1 congruent region, 3 regions total. And we're given the outer circle has radius 6, inner circle has radius 3, and we're given that the probability that a dart will hit a given region is proportional to the area of that region. So we're given when 2 darts hit this board, the score is the sum of the point values in the regions. So we want to know what is the probability that the score is odd. So normally when we solve, so before we get to like the actual calculations, or like before we actually like do the thing, let's first find the probabilities of, like, if I were to throw a random dart, what is the probability it just lands on a 1, right? So we're given that the outer circle has radius 6. So if this outer circle has radius 6, and the outer circle has area 36 pi, right? 6 squared times pi, because, you know, that's just the area of a circle. And we're given the inner circle has radius 3. So this inner circle, this red circle, has radius 3. So the red circle has area 9 pi, right? And that tells us this: if the big circle has area 36 pi and the inner circle has area 9 pi, then this blue region, this region in between the 2 circles, right? This blue region is just 36 pi minus 9 pi, which is 27 pi. And we know that, like, if the area between the 2 circles is 27 pi, we clearly know that each of these 3 regions are like they're symmetrical, so they're like the same area. So that means each of them has area 27 pi divided by 3, so 9 pi. So each of these like regions has area 9 pi. And we know that we found that this red region, right? This like red region in the middle, like we found that it has area 9 pi, and it splits it into 3 congruent regions. So each of these regions has area 9 pi divided by 3, which is 3 pi. So 3 pi, 3 pi, 3 pi. So now what we can do, now let's calculate the total area of the regions that contain a 1, right? So this region has area 3 pi, it contains a 1. And this region here contains a 1, and this region here contains a 1. So 3 pi plus 9 pi plus 9 pi, that equals 21 pi. So the total area of like the regions with a 1 labeled, it's 21 pi. And we can do the similar calculation, and we get 15 pi. So 21 pi for the 1s, and 15 pi, we get the area for the 2s. So we're given that, like, it's proportional. The probability of hitting a number is proportional to the area of the region. So that tells us that the probability of hitting a 1 is 21 pi divided by 36 pi. So that's 7/12. And the probability of hitting a 2 is going to be 15 pi over 36 pi. So that's 5/12. So now what we do is, normally in probability problems, we would find the number of success over the number of possible. But like sometimes another way of finding probability, this is less commonly seen, but occasionally it does appear. It's if you have independent events, then you can multiply the individual probabilities that each event occurs. So in the question, we want to know the probability that the score is odd. So in order for the sum of the 2 numbers to be odd, we must have either the first number be 1, the second number be 2, or the first number be 2, the second number be 1, right? These are the only 2 ways to throw the darts so that we get an odd sum. So let's say we had 1 plus 2. The probability that we hit a 1, so we just found here, the 7/12 is the probability of a 1, and the 5/12 represents the probability of hitting a 2. So the probability of hitting a 1 is 7/12, and the probability of hitting a 2 is 5/12. So to find the probability that you hit a 1 and a 2, we can kind of multiply these 2 together since they're independent events. So 7/12 times 5/12 is equal to 35 over 144. And we can do a similar calculation here for this was for the 1 plus 2 case, but there's also a case for the 2 plus 1. So for 2 plus 1, we would have 5 over 12 times 7 over 12, which would also give 35 over 144. So to find the total probability, the answer would just be 35 over 144 plus 35 over 144. And the answer would just be 35 over 72. And that would just be choice B, and we would be done.